Hello.
Hi there.
Looks like we're still waiting for more people to join. All right, let's begin to this month's UCF TAC meeting. We have a light agenda. We will update people on the project transfer, new conversation with Uber. We'll have a couple of project updates from Hubble GL and VisGL, and then if had a discussion about web GPU. So on the project transfer side for the remaining VisGL frameworks, we had a pretty fruitful conversation last 2 weeks ago with the new OS officer from Uber. She's being appointed onto the UCF board. She's willing to restart the process of the remaining VisGL. She needs to familiar herself with what its current, what has been left off from Brian Xie. But she's very encouraging and in terms of helping us to get the frameworks open sourced into the UCF organization. So that's good to hear, and we will give you guys updates once we hear back from her later on. If you have something about VisGL you want to talk about?
Yes, we are, so we recently released XGL 8.6. We're pretty deep into the, XGL v8 cycle, and there will likely be some more minor releases. But the work is also ongoing on the next major version, and the main thing that's going to create breaking changes is web GPU, and obviously the work starts in LumaGL. So LumaGL is today a WebGL2 framework, a way to work with fairly closely to the GPU, fairly closely to the WebGL2 API, and now we need to change LumaGL so that we can also support in addition to WebGL we can also support web GPU. So the idea is that we will support both. Yeah, I'll probably come back to that a little bit later in the next slide. But and I think we'll see if we actually launch WebGPU in the first version of V9, or it's more a question of enabling, going through the API and making adjustments to the API so that we can plug in WebGPU. And then there's a number of other things also that's happening. There's a lot of change in the JavaScript ecosystem. We have these new ECMAScript modules where you can, if you build and package your modules in a different way, you can actually dynamically import them. So you can do something like await import, which means that you don't have to bundle code. You can dynamically load things. You can load loaders from loaders.gl, layer modules, and so on dynamically when the application needs them, rather than bundle everything up front. And that's definitely something we want to support. And also there's much more modern build tooling. Build is up to 100 times faster than Webpack. Vit is also something that's used, also a much faster tool for setting up examples and so on. So most likely we'll do something in that area. DeckGL is the only framework that the code base hasn't started moving to TypeScript. And so this is something also we're looking at getting in place. And so we would see major versions of bumps of MathGL, loaders.gl, LumaGL, DeckGL. All right, next.
Yeah, so do you want to do your WebGPU stuff and then come back?
Yeah, I think it's best to continue. So what's happening with WebGPU? So it's been development for about 4 years. And we actually, over a year ago, we did a DeckGL native experiment where we did a C++ version of DeckGL that worked on WebGPU. But it's becoming, it has been available under a flag in Chrome for a while. And I believe it's now available in Origin trials. So if you if you register, if you get your URL registered with Chrome, you can enable it. They're still doing final security reviews on it. And my understanding is that they're expected to remove the restrictions in Chrome v99. I don't have the exact date. My guess is that this will be in Q1 of next year. And it would, of course, be wonderful to have day zero support for WebGPU and DeckGL. There's a lot of experimental code in branches, but there's a bunch of work, both getting RFCs, discussions, reviews, and then these breaking changes in the APIs has to be layers and various types of shaders and so on have to be updated, because there's a substantial amount of work. There's quite a bit of changes needed in the LumaGL API, but the changes to DeckGL should be quite small. So we're not trying to kind of shoehorn WebGPU into the WebGL model. That would be too constraining. So we can't make it completely non-breaking. But of course, we're carefully considering how can we minimize the breakage and kind of annoyance for applications.
Can you? I mean, it's for everybody here, like educating us on what is the WebGPU that will, what are the biggest advantage of DeckGL D0 support WebGPU? Some kind of features that will enable us.
Yes, so so GPUs are evolving, and the kind of shader programming model is evolving and has been evolving over the years. And WebGL is based on OpenGL, which is 25, almost 30-year-old procedural API, and it's gotten to a point where it's no longer, there's so many inefficiencies and so much of an impedance mismatch between the OpenGL API and the new the way that GPUs work today and GPU drivers work today, that there was a need for a new API. And this has happened. So, in the Microsoft world, you've moved to DirectX 12. Apple has created the Metal API. The rest of the community has moved to Vulkan. And so those are all three examples of next generation APIs. They all have exactly the same ideas, expose the new GPU model. So you can think of WebGL as a wet blanket that sits on top of the GPU and hides a lot of the capabilities. And one thing that there's many things that comes from web GPU, but you can create proper compute shaders, and those compute shaders can have work groups, and they can do non-local access and have storage buffers, and so there's completely new capability on compute. But the entire API is also designed in a way that it's the objects are much more static. You create different things like textures and buffers and shaders, and you're creating immutable objects, and so there's a lot less validation, and eventually these objects, the GPU objects, you can actually transfer them between threads because they're immutable. That's not in the first version of web GPU, but it's kind of prepared for that. So you could really create multi-threaded GPU applications, and it's just a variety of small improvements across more data types in shaders and more capabilities, and a lot less overhead. The API is designed so that this constant parameter validation that happens is removed.
I think I was wondering about, so right now, like when we work on extensions for DeckGL and we're adding new attributes to the shaders, we hit a limit of, I think, 16 attributes or something like that. Do you know if WebGPU kind of unlocks additional enhancements on that vector where, we can do better extensions and add more attributes to our shaders and
so the size of the attribute bank is a characteristic of the GPU, and what these APIs do is that they tend to define a minimum limit, and that definition of that minimum limit is set in a way so that it would cover all reasonable devices. And as far as I know, that has not been raised in web GPU. So I mean, if the GPU has more, a bigger attribute bank, you should be able to access it, and the same is true it should be true in WebGL, right? But I think basically, if you look at the conclusion is likely that if you look at the cross section of the GPUs that you would access on the devices, that there's still a lot of GPUs out there that we want to address that only have 16 attributes in the attribute bank, and there's no way web GPU can fix that. I have seen frameworks that do pretty tricky things. They pre-compile the shaders to pack virtual attributes into because each basically the attribute bank is a list of it's a 4-element vectors of floats, right? And so you really have each attribute is 16 bytes, right? 4x4 floats. And so you can pack like booleans and other things into bytes and bits. And so if you're willing to mess up your shader code, you can usually get quite a lot of stuff into 16 4-element float arrays, right? But if you want to have like a very clean code where this attribute is an array of booleans, and this is an array of integers, and this is an array of vec2s, then if you're not interleaving them, then you're leaving a lot of the what is called the vertex array bank unused, right? So yeah, I mean, it's unfortunately that's not a problem. The short answer, unfortunately, that's not solved by WebGPU.
Okay.
Yeah, I'm doing a lot of this work right now, and I don't have a lot of help, so I can't I also have other day work to attend to. So obviously, I feel it will be hard. You know, I mean, it's very important for a framework like DECGL to be part of this evolution. I think it'll be. I think it's quite important that we get WebGPU in there, and if anyone is interested in collaborating, participating, helping out, that'd be great.
Do you know if WebGPU enables like future VR or other enhancements? Do you know if trying to understand kind of the future of WebGPU, like where is it going, and where do you see that going into? Does it unlock additional?
Yes, I think you will see. I mean, we're seeing already. I mean, if you can, to get a sense for it, you can look at something like Vulkan, and just like OpenGL, you can see that OpenGL grew over the years with extensions, and then they made new major releases, and they incorporated some of those just extensions into the API, and the extensions are driven by developments on the GPU. So one big thing that's happening is, for instance, hardware ray tracing, and Vulkan already has extension for accessing hardware ray tracing, and so it's reasonable to assume that at some point we're going to get extensions in WebGPU that will allow you to access hardware ray tracing. We don't have support for 64-bit computations on shaders, but most likely that will come as an extension to WebGPU. I think we will see this evolve with the capabilities of GPUs, and GPUs are evolving quite a bit. So, and I think we'll see WebGL really stagnate. I don't think there will be a lot of further development on WebGL at this point.
Sounds like the compute shaders are also a really interesting area. Since we do so much data crunching in the client, it could enhance our analysis capabilities with what we can do, with some JSON that's coming in, or a binary blob of large amounts of data that's coming in.
Yeah, that's something that I was just going to ask, because as we're slowly moving a lot of the data transformation and statistics into GPU-based calculation, and there are definitely still limitations currently, at least when we're trying to look at what kind of statistic GPU can do. Anything with sorting is a non-starter, but I would like to know if there will be more native support, and then some of the limitation can be unblocked by WebGPU.
Yeah, I mean, my naive view is that you have this kind of full, it's like if you can draw this big circle of all the algorithms you can implement on a CPU, and then like you can implement a subset of those algorithms on a GPU, and if all you have is the WebGL, GLSL, WebGL2 model, you can only implement a very small set of those algorithms. And with these GPU shaders, you have a bit more capability, and you can implement like a slightly bigger set of. So, I mean, there's no reason for us not to and there's a lot of interesting, I mean, there's so many details we can come back and provide more
great
information later. All right.
Thanks, Steve. Then go back to, you still have one more slide, but I guess this is already covered.
Yeah, I mean, this is just saying that basically, we're making the we will support WebGL2 and WebGPU. It's not completely clear if we will support WebGL1 in DECGL v9. It can be done. It's extra work on top of all the work, so maybe not immediately. We try to provide a common API for working with both WebGL and WebGPU, but it will probably look more than like WebGPU than WebGL. So the current LumaGL API is very WebGL-ish intentionally, but WebGPU API is more modern, and so there are good parts of that API that we probably want to incorporate. All right.
Hey, so yeah, HubbleGL's like a video rendering library that's probably one of the most recent additions to the VisGL and the different GL libraries that we have. And so I just released a 1.3 version, which really focuses on kind of the stability and the inner workings of the library, which have some really nice external benefit, feature benefits that I listed here that I wanted to just quickly go over. One of the largest kind of out of the gate features that people want and expect from a JavaScript library is that it works with more than just React. And previously, for a variety of reasons, it was very much tied. HubbleGL's rendering engine was very much tied to React's rendering engine, but now it supports Pure.js, and also we released that standalone bundle where you can just inject HubbleGL into the global window namespace, like the DeckGL Lite and LumaGL Lite bundles we have. And so those also have new examples that you can check out if you want to see how they work. But now, from now on, we'll be supporting React, Pure.js, and these standalone bundles in HubbleGL so that you can use that code in any framework, or no framework at all. Another really interesting feature was the ability to load a ton of data in between capturing video frames or image frames in HubbleGL. That's now something that HubbleGL will wait for. It'll wait for DeckGL asynchronous data to load, and also base map data to load. So if you move the camera very quickly and it needs to load a new satellite imagery or something, it will wait for that data to load before it actually takes the screenshot of the frame. And that can be expanded further since it's an exposed flag to other asynchronous data that people using the library might have and be loading in, unrelated to base maps and unrelated to DeckGL's built-in async, but they might be using their own external async. And so, you could imagine wanting to do a time series video of years worth of data where each couple of frames is actually like a gigabyte or more worth of data in that frame, and you would basically load in all that data, capture the frames you need with that data, and then unload that data and load in the next one. And that could all be now driven internally by this waiting feature. And so there's some really interesting applications of this beyond just the kind of intuitive ones where you might have tile data that you need loaded. There's much more than that too that can be done. So I'm excited to see what people do with that. Also, animations can now be updated during runtime. That's one of those internal refactors that led to this. So now, previously the idea was most animations would be defined statically when the page loads, and then there wasn't very great support for allowing the user to modify every aspect of the animation. Certain aspects were very easy to modify, but other aspects were very difficult, and there wasn't a very consistent way of doing it. So now it's very consistent, and you can actually layer on, for instance, you can layer on multiple animation instances, which means maybe you're using a combination of libraries and things that you want to be managed by the animation. So let's say you could simultaneously use a DeckGL instance on its own with a Kepler.gl instance on its own, or maybe you're just trying to animate a HTML element on its own, like let's say a video player, and you want to play or pause or move that video tag, HTML tag to a particular frame and capture it. That all those different elements can now be loaded into this new animation manager that's been released, and you can update what these animation definitions are before you hit render, but during kind of a UI in a user interface, kind of when you're setting up an animation or render. So it's pretty interesting. Renderings can also be embedded now, which means, previously you could always render a video and it would download to your computer, But now you have the option of instead getting the blob or the the array buffer or of the video assets or the GIF or the zip file that contains like image frames, and packing that into and embedding it into your website immediately after rendering. And that can be very great if you have a lot of data that's rendering that doesn't preview well because your GPU can't keep up with it, but you want to kind of iterate on your rendering before actually downloading it, because otherwise you end up with hundreds of things downloaded to your computer that are kind of like drafts or junk, and you just kind of, what you really want is you want to be able to quickly render something that takes a long time to render and then review it, and then after reviewing it decide whether or not it's something you actually want to download and keep. So that's what this feature enables. And
Chris, I have
go
a
ahead.
question here. So for the embedded version, so at least previously at our experience of using it is that if you have way too many frames, like if you make it like more than 10 seconds of a video, and then usually what happens is that your browser just run out of memory to save all the frames that you generated and then just crashes. Would that still happen if it's embedded?
Yeah, unfortunately, there are still ways that you can run out of memory. I don't think there's been a great way of coming up to like address this from a framework or from a library point of view yet.
And well, I was thinking about this. A way of improving this is for the preview, exactly the image size you render. Like many times and you use After Effects, the previews are much smaller image as you run them for people to look at it. And then if you finally want to download a larger one, you can do so. So, that's something that we can think about.
Yeah. I was gonna add that a very similar thing. What I personally do to never run out of memory on my browser is to lower the frames per second and to lower the resolution during kind of these for longer renderings or for preview renderings. And I think documentation improvements can go a long way on helping people learn that is the kind of the technique to use. But what would be ideal is if someone was set up the rendering settings in such a way that was likely going to overload their browser, and we could detect that ahead of time and warn them, hey, wait, you don't want to do that. That would be ideal, but I don't actually know at the moment for all the different file formats, like where that threshold is on the settings. We could throw some warnings maybe on settings that would very likely destroy any computer, but yeah, so that's a good idea though on being able to lower the resolution of previews. And I didn't list it here, but what's coming in 1.4 is a React component and overall better support for changing the resolution at runtime of your renderings too. So there's already a demo in the worldview folder that's in 1.3 of where you can basically just toggle between resolutions at runtime, and it works perfectly. But we'll be bringing that into the library in 1.4 and using it in more components once that's ready. And then, I guess the last thing last two bits are about just the animation classes. There's new animation classes for DeckGL and KeplerGL animation. So you can keyframe any DeckGL layer now, or the map view state in one class where you define the layers that you're going to be animating, the keyframes that will animate those layers, and the keyframes that will animate the map. Same thing goes for KeplerGL filters, layers, trip timestamps, and map state. So there's a consistency now on how to define library or framework integrations. So, if there's some other library that someone wants to create an animation class for, they can do that following this model. And then there's React components. So the KeplerGL export has been polished quite a bit. And then there's a render player component that was added, which is kind of what you can use if you want to embed the renders and not write that component yourself. I just wrote that and added it in, so you don't have to.
So the keyframe for layers, what kind of layer property can be keyframed?
For which library?
So you have the keyframe coupler GL filters layers times the map state. So I'm just asking about layer keyframes. What are the properties that can be keyframed?
Yeah, maybe it'd be more accurate to say viz config, since it's the viz config that can be
Right.
keyframed. So that's what that is. Yeah, anything that's in viz config. So
Got it. Thank you. This is great. I think we should also plan to upgrade to 1.3 next spring for us for Unfolded, so we can getting some of the improvements on there too.
cool. Yeah, and 1.4 should add some more features on top of all this. I think 1.3 is a really good stability release, and I'm excited to like be expanding the features over the next few releases.
And I think as we talk about, it will be nice for the keyframes, coupler filters layer times down. We have simple UIs that allow people to edit the keyframes. I'm sure right now you were just using the manually coding the keyframes, and for user, it would be nice to have some kind of UI. So
Totally.
that they don't have to write code there.
Yeah, like now you can update the animations at runtime, but there's no good UI examples out there of how you do that right now. So that would be, kind of the next step for the library to start to explain like how you go about doing those kinds of things.
Okay. Great. Thank you for the update. I think that just conclude our meeting today. For the next meeting, it's going to be somewhere near Thanksgiving. I think it's going to be the Thursday before. Wait, no, actually, it's going to be on Thanksgiving because we are we're on the Thursday. So
yeah, it is funny.
Right, so I'm inclined to cancel the next meeting or move it to the Thursday after Thanksgiving. Does anyone have any idea or suggestions on what should we do? I think it just appear me and Chris going.
Moving it would be good. I mean, I think having the monthly cadence is good. If we want to move to after Thanksgiving, that's fine with me.
Yeah, or we can move it to Wednesday just for that week, so before Thanksgiving. I'll send out a survey or just asking people around to see.
Okay.
Great. Yeah, because after
aren't we all out the Thanksgiving week?
Yeah,
we are all out the Thanksgiving week.
Yeah.
All the US.
Right.
Yeah.
Good point.
Not Johanna.
Hi. Yeah, I joined a bit later, but yeah, no worries. Yeah.
But also the following month is Christmas, right? So we have to. I guess Christmas is also for European folks, right? So it's same. We might need to also move that one, or just consolidate into one meeting.
End of year Christmas meeting.
Yeah.
So we should all wear like some Santa Claus caps.
Yeah,
like that.
I like that.
With some nice visualization.
Yeah, with the reindeer flying behind us.
Yes.
All right, so let's. I'm gonna move the meeting to at least for the Thanksgiving one. I'm going to move to the next Thursday after that, and we'll talk about Christmas when it comes.
All right.
Thank you, guys.
Have a great rest of the day.
You too.
Yeah.
Thank you.
Enjoy. Bye.
Bye.
Bye.